Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 6th class on vector algebra. Till now, we learned theory part related to first exercise and we completed first exercise problems of NCERT textbook exercise number 10.1 from vector algebra. In case if you didn't watch those videos, I'll give that playlist link in cards here. In this class, we are going to learn about addition of vectors. In this addition of vectors only, you will learn triangle law of vector addition and parallelogram law of vector addition. Triangle law of vector addition, parallelogram law of vector addition are very important things which will be useful throughout this vector algebra chapter. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. In this class, we will learn how to add two vectors. How the addition of vectors is defined that we are going to learn. For that, I will consider two vectors like this. You observe this diagram, I consider two vectors A bar, B bar. Here, I will name the vector A bar as OA bar. I will name like this. If you want, you can keep it as AB bar also. Just for our convenience, I written here A bar as OA bar. And I'll name this B bar as AB bar. Okay, the same thing I written here. Let A bar comma B bar are two vectors such that A bar is OA bar, B bar is AB bar. Now we will learn how to add these two vectors. You may get doubt that if A bar B bar are not like this, then how we add the vectors? Suppose two vectors are like this, A bar B bar. How to add these vectors? You know that in vector algebra chapter, whatever vectors we will consider, they are all free vectors. In case if the vectors are like this, then can we add vectors? Yes, we can add. To add these two vectors, what I'll do, this second vector is there, na? Without changing its direction, I'll shift this second vector to here. Because we know that these vectors are free vectors. These vectors are independent from its position in space. This B bar, I can shift to here without changing its magnitude and direction. Now further I can add. So what happened here? I consider two vectors A bar, B bar such that OA bar is A bar, AB bar is B bar. Then to define addition of these two vectors, first point, if this is OA bar na, I will consider this as first vector. This is AB bar na, I will consider it as second vector. The terminal point of first vector and initial point of second vector must be same. To add these two vectors, terminal point of first vector, initial point of second vector must be same. So what happened? I considered two vectors A bar, B bar like this. Then addition of vectors A bar comma B bar is denoted by A bar plus B bar. That addition is defined as, listen this carefully. The addition is defined as the directed line segment joining from initial point of a first vector to the terminal point of a second vector. You join them. This is the initial point of first vector. This is the terminal point of second vector. You join them. You observe here how it is defined as directed line segment. Addition of these two vectors is defined as directed line segment joining from where to where? Initial point of first vector. See, this is the initial point of first vector to the terminal point of second vector. So, what is this vector? This vector is A bar plus B bar. Very simple. This is addition of vectors. I'll quickly recall what is the definition of addition of vectors. Let A bar comma B bar are two vectors such that OA bar equal to A bar and AB bar equal to B bar. Here what point you need to understand, the terminal point of first vector, initial point of second vector must be same. Then addition of vectors A bar comma B bar is denoted by A bar plus B bar and it is defined as directed line segment joining from initial point of a first vector to the terminal point of second vector. Whatever I written here in simple words, you look here OA bar plus AB bar. You observe here OA bar plus AB bar. What is addition of these two vectors? You observe the terminal point of first vector, initial point of second vector are same. What is OA bar plus AB bar? OA bar plus AB bar is OB bar, it is a directed line segment joining from initial point of a first vector to the terminal point of second vector. This is very easy only. Here direction plays important role. You observe A bar B bar direction, you observe A bar B bar, A bar B bar direction is like this. Now you observe addition of these two vectors, that means resultant of these two vectors. Resultant of these two vectors is opposite direction of A bar B bar. What is the direction of this vector? It is going like this. This is opposite direction of A bar comma B bar. So this is the definition of addition of vectors. Now we will learn what is triangle law of vector addition. You observe here there is a triangle OAB, right? In this triangle, A bar B bar are the two sides of the triangle. A bar B bar are the two sides of the triangle. You observe their direction. Okay, the resultant of these two vectors is the third side of the triangle, which is opposite direction of A bar comma B bar. If A bar comma B bar are any two sides of a triangle like this, then the resultant of these two vectors A bar plus B bar is the third side of the triangle, which is opposite direction of A bar comma B bar. So I explained this addition in a triangle, that's why this is known as triangle law of vector addition or triangle law of addition of vectors. Simply whatever I written here, this is the definition of addition of vectors, which is same as triangle law of vector addition. Now I'll discuss two very important point which we use very frequently throughout this chapter. You observe here OA bar plus AB bar is OB bar. From this, can I write AB bar? Note 1. From this, what is AB bar? AB bar is, you take OA bar to other side, AB bar is OB bar minus OA bar. In earlier classes, you learned what is OB bar. OB bar is position vector of point B. What is OA bar? OA bar is position vector of point A. Here important thing is AB bar can be written as OB bar minus OA bar. That is important. AB bar can be written as OB bar minus OA bar. This we use very frequently while doing exercise problems. Whenever you see AB bar, if you know OB bar, OA bar, then AB bar can be written as OB bar minus OA bar. Not only AB bar, suppose you saw somewhere BC bar. BC bar is there. The vector BC bar can be written as OC bar. Look here, OC bar minus OB bar. Suppose you want to calculate PQ bar. You know OP bar, OQ bar. Already given that information. Then PQ bar can be written as OQ bar minus OP bar. This is the point we use very frequently. How we got this? This we got from addition of vectors only. Second note point. From addition of vectors, you learn this point. OA bar plus AB bar is OB bar. OA bar plus AB bar is OB bar. If you observe here, terminal point of first vector, initial point of second vector is same. Then addition of these two vectors is the directed line segment joining from initial point of a first vector to the terminal point of a second vector. That is nothing but OB bar. From this also, whenever you see something like this, AB bar plus BC bar, you saw this, AB bar plus BC bar. You see, terminal point of first vector, initial point of second vector, both are same. AB bar plus BC bar can be written as AC bar. This is also point we use very frequently from now onwards. Something you saw like this, BC bar plus CA bar. BC bar plus CA bar can be written as BA bar. How we are writing all these things? We are writing all these things from the definition of addition of vectors. These two note points are very important. Note 3. Commutative law holds good with respect to addition. That means A bar plus B bar is same as B bar plus A bar. A bar plus B bar is same as B bar plus A bar. I'll try to explain why A bar plus B bar is same as B bar plus A bar. You already learned about this addition of vectors. Na? This is the triangle. Now what I'll do, I'll form a parallelogram from this. You observe here, I formed a parallelogram OABC. You suppose this is a parallelogram. Now, what is this vector? We know that in a parallelogram, opposite sides are of same magnitude. What is OC bar? OC bar, AB bar will be of same magnitude and same direction. So this is the vector B bar. And what about this CB bar? CB bar is same as A bar. If this is A bar, this is also A bar because these are equal vectors. Okay. So you observe these vectors OC bar. You observe this OC bar plus CB bar. You learn this now. As per that, OC bar, see here, OC bar plus CB bar. OC bar plus CB bar is what? OC bar plus CB bar is OB bar na, right? OC bar is B bar, CB bar is A bar, B bar plus A bar, B bar plus A bar is OB bar. Actually, what is OB bar? OB bar is, what is OB bar? OB bar is A bar plus B bar, right? Here, OC bar is what? OC bar is B bar, CB bar is A bar, OC bar plus CB bar is OB bar. That means B bar plus A bar. You observe this B bar, A bar in this direction. Na? This vector is opposite direction of these two. Na? This is B bar plus A bar. This tells you that A bar plus B bar is same as B bar plus A bar. Please think little bit. You can understand this very easily. So, what is the third note? Commutative law holds good with respect to addition of vectors. With respect to vector addition, associative law also holds good. A bar plus B bar plus C bar is same as A bar plus B bar plus C bar. Okay. And identity law also exists. That means A bar plus 0 bar 0 equal to 0 bar plus A bar equal to A bar. So what you learned till now? You learned what is addition of vectors and you learned what is triangle law of vector addition. Now we will learn what is parallelogram law of vector addition or parallelogram law of addition of vectors. To explain what is parallelogram law of vector addition, I consider two vectors A bar comma B bar are two vectors such that OA bar equal to A bar, AB bar equal to B bar. This is like as usual how we taken the vectors in addition of vectors. In the same way, I taken OA bar as A bar, AB bar as B bar. I consider two vectors like this. Now you can observe 3 points are there, OAB. Now what I'll do, I'll form a parallelogram OABC with the help of these two vectors. You observe here, I drawn a parallelogram OABC. You know that if OA bar equal to A bar, AB bar equal to B bar, you know that what is OB bar. What is this OB bar? OB bar is addition of these two vectors. OB bar is A bar plus B bar. What is OB bar? OB bar is A bar plus B bar. You keep this in your mind. OB bar is diagonal of this parallelogram. Okay. You observe the vectors AB bar and OC bar. As it is a parallelogram, these two will have of same magnitude. And what about their direction? AB bar is in this direction. OC bar is in this direction. AB bar, OC bar are equal vectors. The vectors AB bar, OC bar clearly equal vectors. Equal vectors means AB bar is B bar na, OC bar also B bar. What is this OB bar? OB bar is A bar plus B bar. Here, what you need to know, what is parallelogram law? You observe OA bar, OC bar. OA bar, OC bar. They are the adjacent sides of a parallelogram with the same initial point. What is this OB bar? This is the diagonal with the same initial point. Something we are getting a point here. In a parallelogram, if A bar comma B bar are the adjacent sides of a parallelogram with the same initial point, then A bar plus B bar is one of its diagonal with the same initial point. This is parallelogram law of vector addition. You need to catch this point. Listen this carefully. Here A bar comma B bar are the adjacent sides of a parallelogram with same initial point. When we add these two, A bar plus B bar is the diagonal of that parallelogram with the same initial point. This is known as parallelogram law of vector addition. So here I'll write the same point. You observe OA bar comma OC bar, OA bar comma OC bar are the adjacent sides of a parallelogram with same initial point. Then OA bar plus OC bar, that means addition of these two vectors. OA bar plus OC bar is the diagonal of the parallelogram with the same initial point. That is important. This is important, with the same initial point. If we add OA bar plus OC bar, you will get OB bar. So what is parallelogram law of vector addition? If A bar comma B bar are the adjacent sides of a parallelogram with the same initial point, then addition of those two vectors is the diagonal of the parallelogram with the same initial point. This is known as parallelogram law of vector addition. Now I will discuss one point related to parallelogram law of vector addition. With that, you will get more clarity on parallelogram law of vector addition. As per the parallelogram law, we can say this point also. AB bar, AO bar are the adjacent sides of a parallelogram with same initial points. AB bar plus AO bar are the adjacent sides of a parallelogram with same initial point A. Addition of these two vectors will gives you what as per parallelogram law of vector addition? AB bar plus AO bar will gives you the diagonal of parallelogram with same initial point. That means you will get AC bar as per the definition of parallelogram law. Parallelogram law says that there are two adjacent sides of a parallelogram with same initial point. Addition of those two vectors will gives the diagonal of that parallelogram with the same initial point. It is very simple. I hope you are understanding. I hope you understand this. In this class, we learn addition of vectors. In addition of vectors, we learn about triangle law of vector addition and we learn about parallelogram law of vector addition. I hope you understand this class. If you like this video, please drop a like and share this video with your friends so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye. Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 7th class on vector algebra. In last class, we learned about triangle law of vector addition and parallelogram law of vector addition. To understand this class, that class knowledge is compulsory. In case if you not watched that video, I'll give that video link in cards here. In this class, we will learn what is I cap, what is j cap, what is k cap and what are its directions. And if p of x comma y is a point in a plane, then y we will write OP bar as xi bar plus yj bar. I am going to explain why OP bar as xi bar plus yj bar, why magnitude of OP bar as root over x square plus y square. And if p of x comma y comma z is a point in a space, then y we will write OP bar as xi bar plus yj bar plus zk bar and y magnitude of OP bar as root over x square plus y square plus z square. This class is for those who want to learn geometrical meaning behind these formulas. First, we will learn what is I cap. In the definition of unit vector, you learn about this cap symbol. A cap means A bar is a unit vector. Okay, so here what is I cap? I cap is a unit vector along the direction of x-axis. You observe this three-dimensional figure, x-axis, y-axis, z-axis. What is I cap? I cap is a unit vector along the direction of x-axis. That means you observe here, this is the direction of I cap. As it is a unit vector, its magnitude is 1 unit. What is this vector? This vector is I cap. What is I cap? I cap is a unit vector along the direction of x-axis. What is magnitude of I cap? As it is a unit vector, magnitude of I cap is 1. From now onwards, whenever you see I cap, you need to memorize this point. I cap is a unit vector along the direction of x-axis. Okay. Now what is j cap? J cap is a unit vector along the direction of y-axis. This is y-axis now. What is the direction of j cap? J cap is a unit vector along the direction of y-axis. Similarly, what is k cap? K cap is a unit vector along the direction of z-axis. From now onwards, you keep this point in your mind. What is I cap? I cap is a unit vector along the direction of x-axis. What is j cap? J cap is a unit vector along the direction of y-axis. What is k cap? K cap is a unit vector along the direction of z-axis. Now, I will consider a point A on x-axis. Suppose this is the point A on x-axis. I'll take that this length OA as x. I don't know what is this length. I'll suppose this length OA as x. What is OA bar? OA is x and OA bar is along the direction of x-axis. Then OA bar can be written as xi cap. What is this xi cap? In earlier classes, you learned about scalar multiplication of a vector. At that time I said that is very important. In case if you not watched that video, I'll give that video link in cards here. You please check that video without fail. You know about the vectors a bar and ma bar. When m is positive, a bar, ma bar will have the same direction. Here x means OA, distance. X is clearly positive here. So this is like ma bar. What is the direction of xi bar? What is the direction of ma bar? The direction of ma bar is along the direction of a bar. What is the direction of xi cap? The direction of xi cap is along the direction of I cap. What is I cap? I cap is along the direction of x-axis. So I written OA bar as xi cap. Xi cap is a vector along the direction of x-axis. That point is clear. Now, what is magnitude of OA bar? Magnitude of OA bar. Magnitude of OA bar. Here OA bar is xi cap. You know this formula. Magnitude of ma bar is m into magnitude of a bar when m is positive. Here x is clearly positive because the length OA is x. This can be written as x into magnitude of I cap. So this equal to x into what is magnitude of I cap? I cap is a unit vector, na? Its magnitude is 1. So x into 1 is x. What I am trying to say, if OA is x, then OA bar can be written as xi cap. That is the main point I want to say. I'll consider a point B on y-axis. You suppose that the length OB is y. You suppose the length OB is y. OB bar is along the direction of y-axis and OB equal to y. That's why OB bar can be written as y into j cap. OB bar can be written as y into j cap. Similarly, if I take a point C on z-axis, such that OC equal to z. OC bar is a vector along the direction of z-axis, na? So here OC bar can be written as z into k cap. So finally what I want to say, if you know that A is a point on x-axis and OA equal to x, then OA bar can be written as x into I cap. If you know that B is a point on y-axis and OB equal to y, then OP bar can be written as y into j cap. If C is a point on z-axis, we know that OC is z, then OC bar can be written as zk bar. Now we will learn about component of a vector in two-dimensional geometry. If P is equal to x comma y, then y we write OP bar as xi cap plus yj cap, and y we write magnitude of OP bar as root over x square plus y square. This we are going to learn now. I will consider a point x comma y in a plane. This is in two-dimensional geometry, na? That's why I considered x-axis, y-axis. This is origin. Now P of x comma y is a point in a plane. I'll take the point P here. The point P is x comma y. As you taken P is x comma y, this length is x, this length is y. Now you observe, I'll take this as point A, I'll take this as point B, and this is the origin O. As this length is x, this length is also x. Okay, as this length is y, this length also y. I hope you are understanding. As you know, OA is x and OA bar along the direction of x-axis. OA bar can be written as xi cap. Just now we learned this. Okay, now you observe here, we know that OB is y and OB bar is along y-axis, na? So OB bar can be written as, the vector OB bar can be written as y into j cap. What I am trying, you observe here, if P is x comma y, OP bar means position vector of a point P. I need OP bar. You observe the director line segment OP bar. I want this director line segment OP bar. I want to prove that this OP bar is xi cap plus yj cap. In last class, we learned about triangle of vector addition. To apply that, I need a triangle here. So what I'll do, I'll join these 2 points. Then you see here, you can get the vector AP bar. You observe here, AP bar, OB bar. They are equal vectors. They are having same magnitude. They are in the same direction. So AP bar, OB bar are equal vectors. So OB bar can be written as AP bar. in last class you learned about triangle law of vector addition. You see OA bar plus AP bar, OA bar plus AP bar. See here, terminal point of a first vector, initial point of a second vector, both are same. Then what is addition of these two vectors? Addition of these two vectors is defined as direct line segment joining from initial point of a first vector to the terminal point of a second vector. OA bar plus AP bar is OP bar. This is what we learn in triangle law of vector addition. In case if you not watched that video, please watch last class. Okay, right. Now what I am trying for? I am trying for OP bar. Right. OA bar. You know what is OA bar. What is OA bar? OA bar is xi cap plus what is AP bar? AP bar is yj cap equal to OP bar. What we are trying for? We are trying for OP bar only na. OP bar is xi cap plus yj cap. Here we got the same thing. OP bar is xi cap plus yj cap. So now you got the point. If p equal to x comma y OP bar as xi cap plus yj cap. Now we will learn if p equal to x comma y magnitude of OP bar is root over x square plus y square. That we will learn now. In representation of vectors, you learn that magnitude of AB bar is AB, distance between the points A and B. Magnitude of BC bar is BC. Similarly, magnitude of OP bar is distance between the points O and P. Magnitude of OP bar is OP. Here what is O? O is origin. P, what is P? P is x comma y. You know that origin is 0 comma 0 and the point P is x comma y. OP is nothing but distance between these 2 points na. You already learned the distance between 2 points formula in two-dimensional geometry. What is the distance between 2 points formula? Root over. You take this point as x1 comma y1, you take this point as x2 comma y2. What is the distance between 2 points formula? x2 minus x1 whole square plus y2 minus y1 whole square. So here x2 minus x1, that is x minus 0 whole square plus y2 minus y1, that is y minus 0 whole square. That equal to root over x minus 0 is x na, x square plus y square. So magnitude of OP bar is what? Magnitude of OP bar is root over x square plus y square. I hope you understand now. If p equal to x comma y, then y we are writing OP bar as xi cap plus yj cap, and y we are writing magnitude of OP bar as root over x square plus y square. I hope you understand this. However, it is in two-dimensional geometry now. This can be understood easily. Now we will discuss about components of a vector in three-dimensional geometry. That is little complicated to understand. Please focus more to understand it clearly. Components of a vector in three-dimensional geometry. What we are going to learn in this, if we take a point P x comma y comma z in a space, then y OP bar is xi cap plus yj cap plus zk cap, and y magnitude of OP bar is root over x square plus y square plus z square. To explain this, I consider a three-dimensional geometrical figure. You see here, this is x-axis, y-axis. This is z-axis. Okay. Now, P of x comma y comma z is a point in space na. Where is that point? See, this is the point P of x comma y comma z. This is the point P. Okay. To explain this clearly, I'll use this. This is like a cube. I'm going to use this to explain this. You observe this. These are like, this is x-axis. Please observe this. This, you see, this is x-axis. Okay. And this is y-axis. And this is z-axis. This line. Listen, this is x-axis. This one is y-axis. This one is z-axis. Where is the point P? This is the point P. This is the point P. X-axis, y-axis, z-axis. This is the point P. I cannot go through each and every point in detail, as the point P is x comma y comma z. The point A on x-axis is x comma 0 comma 0. What you learn in class 11 three-dimensional geometry, coordinates of a point. And this is the point B on y-axis. And as the point P is x comma y comma z, the point B on y-axis will be 0 comma y comma 0. As the point P is x comma y comma z, the point C on z-axis will be 0 comma 0 comma z. Okay. this tells you that the length OA, what is length OA? OA is X. The length OB is Y. The length OC is Z. So as you know, the length OA is X and OA bar is along X axis. OA bar can be written as X into I cap, and you know that the length OB is Y and OB bar is along Y axis, then OB bar can be written as Y into J cap. You know that OC is Z and OC bar is along the direction of Z axis. OC bar can be written as Z into K cap. Now what I am trying for? I am trying for OP bar. You observe this, as I am saying from the beginning, this is X axis, this is Y axis, this is Z axis. What I need, this is the point P, this is the point P. What I need OP bar. Okay, to calculate OP bar, what I'll do, I'll draw PD. I'll draw PD, which is perpendicular to this plane. You can observe that in this diagram. This is PD. See, this is point P na? This is point P na? This is PD. You can observe this in the diagram. This is PD. This is the point D. Okay. Now to calculate this OP bar, I'll calculate OD bar, because you can observe in this OD bar plus DP bar. OD bar plus DP bar is the OP bar. You learn about triangle of vector addition. OP bar is OD bar plus DP bar. You came to know that OP bar is OD bar plus DP bar. From triangle of vector addition, you can easily say this is the terminal point of first vector, this is the initial point of second vector. So when we add these two vectors, you will get a direct line segment joining from initial point of a first vector to the terminal point of a second vector. You know that OD bar plus DP bar is OP bar. Okay, now I'll calculate OD bar. What is OD bar? Now you please try to understand. I am trying to calculate OD bar. I am trying to calculate OD bar. OD bar is OA bar plus AD bar. OD bar is OA bar plus AD bar. What is AD bar? AD bar and this OC bar. AD bar and OC bar, they are equal vectors. Please try to understand. What I need now? I need this OD bar. Okay. OD bar can be written as OA bar plus AD bar. Okay. OA bar is very clear. OA bar is what? OA bar is XI cap. Now AD bar. What is AD bar? AD bar, OC bar are equal vectors. OA bar plus AD bar. AD bar, OC bar are equal vectors. In place of AD bar, I can write OC bar, because AD bar, OC bar are equal vectors. What is OA bar? OA bar, you know what is OA bar? OA bar is XI cap. XI cap. OC bar is what? OC bar is ZK cap. ZK cap. Okay. Now you got OD bar, XI cap plus ZK cap. Now you know what is OD bar. Now you need to calculate DP bar. If you observe this diagram, you can easily understand that this DP bar and OB bar are equal vectors. So what I'll write here, this equal to OD bar plus DP bar. DP bar and OB bar. DP bar and OB bar are equal vectors. In place of DP bar, I can write OB bar. What is OD bar? You got there. What is OD bar? OD bar is XI cap plus ZK cap plus. What is OB bar? OB bar is YJ cap. OB bar is YJ cap. You see here XI cap plus YJ cap plus ZK cap. So if I write in correct order, what you will get? XI cap plus YJ cap plus ZK cap. So you got what is OP bar. So if P of x comma y comma z is a point in a space, then OP bar is XI cap plus YJ cap plus ZK cap. Now I hope you understand. This is not so easy to explain in two-dimensional. What you are watching, that is two-dimensional geometry. I strongly recommend, in case if you are interested to know what is happening, you take a geometrical figure, 3D geometrical figure like this. You identify what is x-axis, what is y-axis, what is z-axis, what is OABC, Where is point P? Where is point D? What is OD bar? What is DP bar? You observe. You can understand easily. So here I came to know this point. If P equal to x comma y comma z, OP bar is xi cap plus yj cap plus zk cap. Magnitude of OP bar is root over x square plus y square plus z square. That I need to prove. Okay. Magnitude of OP bar. You know that magnitude of OP bar is nothing but OP. What is O? O is origin 0, 0, 0. P is x comma y comma z. You know in class 11 three-dimensional geometry, distance between 2 points in three-dimensional geometry you learn. Root over x2 minus x1 whole square, that is x minus 0 whole square, plus y2 minus y1 whole square, that is y minus 0 whole square, plus z2 minus z1 whole square, that is z minus 0 whole square. I consider this point as x1 y1 z1, this point as x2 y2 z2. Now, so x minus 0 whole square is x square, plus y minus 0 whole square is y square, plus z minus 0 whole square is z square. So you got that magnitude of OP bar is root over x square plus y square plus z square. I think I tried my best to explain these things clearly. I hope you understand this class. If you like this class, please drop a like for this video and share this video with your friends so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye. Hello everyone. I am Balaji Rao. Welcome to BR Max class. Till now, whatever we learned in vector algebra chapter, in case if you not watched those videos, I'll give that videos playlist link in cards here. In this class, we will learn about direction cosines and direction ratios of a vector. This concept is important one. We use this concept very frequently throughout the chapter vector algebra as well as three-dimensional geometry also. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. In last class, we learned about this. If P equal to x comma y comma z is a point in a space, if I consider a point P in a space, then y we will write OP bar as xi cap plus yj cap plus zk cap, and y magnitude of OP bar is root over x square plus y square plus z square. These things I explained in last class. In this class, what we are going to learn? In this class, we will learn direction cosines and direction ratios of a vector OP bar. You observe this diagram. To explain this, I consider a three-dimensional geometrical figure. You see, this is x-axis, this is y-axis, this is z-axis, and point of intersection of these three things is origin. Now, what I am saying, I will consider a point P in a space. You observe, this is the point P in a space. Here, P is x comma y comma z. What I am trying for? I am trying to find direction cosines of a vector OP bar. Where is OP bar? You observe, this is OP bar. Little difficult to understand this. So to explain, I'll consider a figure of this shape. You observe, I consider a shape of this diagram. Now you try to understand what is happening exactly. You see, listen carefully. This is x-axis, this is y-axis, and this is z-axis. Look here. Okay. Now I consider a point P in a space now. See, x-axis, y-axis, z-axis. See, this is the point P. P. What is P? P I consider as x comma y comma z. Where is OP bar? You see, this is some vector. You know that this point is O. See, this is OP bar. I'll suppose this is OP bar. P point here. This is OP bar. If you want to understand this more clearly, you also consider a three-dimensional geometric figure like this so that you can understand it very easily. Now you know what is OP bar. Now what I'll consider? You observe here. Let alpha, beta, gamma are the angles made by vector OP bar with x-axis, y-axis, z-axis respectively. See here, this is OP bar na. This makes an angle alpha with x-axis. This makes an angle beta with y-axis. This makes an angle gamma with z-axis. See, this is OP bar na. You observe this is the angle made by OP bar with x-axis. You observe this angle is alpha. This angle is alpha. This is the angle made by OP bar with y-axis. This is the angle. So this is the angle beta. Now you observe this is z-axis na. This is the angle made by OP bar with z-axis. I taken this angle as gamma. What I considered? OP bar makes an angle alpha with x-axis, makes an angle beta with y-axis, makes an angle gamma with z-axis. Then the direction cosines of a vector OP bar is defined as cos alpha, comma, cos beta, comma, cos gamma are called direction cosines. See, this is the standard notation of direction cosines. Direction cosines I can write directly like this. This is direction cosines of a vector OP bar. This is definition of direction cosines of a vector OP bar. I'll quickly recall what is the definition of direction cosines of a vector OP bar. Let P of x comma y comma z is a point in a space. Let the vector OP bar makes an angle alpha with x-axis, makes an angle beta with y-axis, makes an angle gamma with z-axis. Then cos alpha, comma, cos beta, comma, cos gamma are called direction cosines of the vector OP bar. In trigonometry, cos means cosine function, tan means tangent function. With the help of cos alpha, cos beta, cos gamma, we can find unique direction of the vector OP bar. With the help of cos alpha, cos beta, cos gamma, I can identify exact direction of the vector OP bar. Now you understand the definition of direction cosines of a vector. You learn about direction cosines of a vector OP bar. What about direction cosines of a vector PO bar? What are the direction cosines of a vector PO bar? You please observe this is OP bar. You look here, this is the angle alpha made by OP bar with x-axis. What is the angle made by PO bar with x-axis? What is the angle made by PO bar with x-axis? Not this one. This is angle made by OP bar. This is PO bar na. This is the continuation of PO bar. What is the angle made by PO bar with x-axis? You observe this. This is the angle. You consider a three-dimensional figure like this so that you can understand this easily. Sum of this angle plus this angle is 180 degrees na. So this angle is 180 degrees minus alpha. What I said, if OP bar makes an angle alpha with x-axis, then PO bar makes an angle 180 degrees minus alpha with x-axis. This is the point you need to catch. To understand this more clearly, this type of geometrical figure you take and you try to understand what I am saying, then you can understand this very easily. If OP bar makes an angle alpha with x-axis, then PO bar makes an angle 180 degrees minus alpha with x-axis. If OP bar makes an angle beta with y-axis, then PO bar makes an angle 180 degrees minus beta. If OP bar makes an angle gamma with z-axis, then PO bar makes an angle 180 degrees minus gamma with z-axis. So, what is first note point? If alpha, comma, beta, comma, gamma are the angles made by the vector OP bar, then 180 minus alpha, comma, 180 minus beta, comma, 180 minus gamma are the angles made by PO bar with x-axis, y-axis, z-axis respectively. These are the angles made by the vector PO bar, not OP bar. So, what are the direction cosines of PO bar? Cos pi minus alpha, comma, cos pi minus beta, comma, cos pi minus gamma are the direction cosines of PO bar. What are these? These are the direction cosines of the vector PO bar. Cos 180 minus alpha. You know that from trigonometry, cos 180 minus theta is minus cos theta. So minus cos alpha. Cos pi minus beta is minus cos beta. Cos pi minus gamma is minus cos gamma. So minus cos alpha, comma, minus cos beta, comma, minus cos gamma are the direction cosines of a vector PO bar. Here one important point I am trying to say. Now I'll discuss direction cosines of a line. If I take a line OP, then what are the angles made by this line OP with x-axis, y-axis, z-axis? Alpha, beta, gamma are one set of angles made by OP with x-axis, y-axis, z-axis respectively. At the same time, 180 minus alpha, 180 minus beta, 180 minus gamma are the angles made by line, L-I-N-E, line, made another set of angles made by line OP with x-axis, y-axis, z-axis respectively. So when we speak about direction cosines of a line, cos alpha, cos beta, cos gamma are the direction cosines of a line. At the same time, minus cos alpha, minus cos beta, minus cos gamma also direction cosines of that line. That means you will get two sets of direction cosines of a straight line. In general, direction cosines of a vector are denoted by L, M, N. That means L is what? L is cos alpha, M is cos beta, N is cos gamma. We use this L, M, N very frequently from now onwards. Third note point is very important. To understand this, you must know what is cos theta. We know that cos theta is adjacent side divided by hypotenuse. This is the definition we learn in trigonometry. So here I'll calculate what is cos alpha with the help of this diagram. P of x comma y comma z is any point in a space. If P is x comma y comma z, what is this point on x-axis? I'll take this point as A. You observe this x-axis, y-axis, z-axis. This is point P. Where is point A? Where is point A? Point A is on x-axis. Look here. This is point A. I hope you are understanding. This is point A. This is x comma y comma z na. X coordinate is the perpendicular distance from point to yz plane. See, this is y-axis, this is z-axis na. This plane is yz plane. So this length is what? This length is the x coordinate. As P is x comma y comma z, this length is x. If this length is x, you observe, this length is also x. So what is A? As point A is on x-axis, its y coordinate, z coordinate are 0. So what is A? A is x comma 0 comma 0. So if the point P is x comma y comma z, then the point A is x comma 0 comma 0. Similarly, if I consider this point on y-axis as B, this point B will be 0 comma y comma 0. Why? Because P is x comma y comma z. As P is x comma y comma z, if I consider this point as C, this point is 0 comma 0 comma z. I hope you are understanding. You observe this diagram carefully. The triangle OAP forms a right angle triangle. This is O, this is A, this is point P. Observe this carefully. OAP. P means it comes here like this. You observe here. It comes like this. This is point A. This is point P. AP will come like this. I hope you are understanding. What I am trying to say, if you observe carefully this diagram, the triangle OAP forms a right angle triangle. It is right angle at this point. And this is the alpha. What is cos alpha? Cos alpha is adjacent side by hypotenuse. Whatever the angle is there opposite to alpha, that is known as opposite side. That means AP is the opposite side. OA is the adjacent side. OP is the hypotenuse. OP is the hypotenuse. I hope you understand this. You consider something boxed like this and you try to imagine what I am saying, then you can understand very easily. So in triangle OAP, you identified that OA is the adjacent side, OP is the hypotenuse. Cos alpha formula is what? What is cos alpha formula? Cos alpha formula is adjacent side by hypotenuse. What is adjacent side? OA divided by what is hypotenuse? Hypotenuse is OP. OP is nothing but magnitude of OP bar. Magnitude of OP bar is OP na, that we learned in last class also. Okay. What is OA? You see, this point A is x comma 0 comma 0 na. What is this length OA? OA is x. So OA is x divided by magnitude of OP bar. In last class we learned if P is x comma y comma z, magnitude of OP bar is root over x square plus y square plus z square. So what is magnitude of OP bar here? Magnitude of OP bar is root over x square plus y square plus z square. So you got cos alpha. Similarly, I'm not going to explain like this. Similarly, cos beta. What is cos beta? Cos beta is y divided by root over x square plus y square plus z square. What about cos gamma? cos gamma is z divided by root over x square plus y square plus z square. So this is the final point what I want to say. If p equal to x comma y comma z, then direction cosines of OP bar formula is what? Very very important. X divided by root over x square plus y square plus z square, y divided by root over x square plus y square plus z square, z divided by root over x square plus y square plus z square. What is the relation between L, M, N? If you observe this L square plus M square plus N square value, what is L? L is cos alpha. This is L. This is what? This is L. This is M. This is N. L square. What is L square? Square this. Square this. What is L square? You will get L square as x square divided by, when we square this root will get cancelled now, x square divided by x square plus y square plus z square plus M square. What is M square? M square is y square divided by x square plus y square plus z square. What about N square? N square is z square divided by x square plus y square plus z square. You observe LCM. What is LCM here? LCM is x square plus y square plus z square. So in the numerator what you will get? In the numerator you will get x square plus y square plus z square. If both will get cancelled, you will get 1. So this is the fourth note point. L square plus M square plus N square value is 1. Even though the video is getting lengthy, I'll try to quickly recall what you learned about direction cosines of a vector. Let P equal to x comma y comma z is a point in a space, and the vector OP bar makes an angle alpha with x-axis, makes an angle beta with y-axis, makes an angle gamma with z-axis. Then cos alpha, cos beta, cos gamma are known as direction cosines of a vector OP bar. And we learned that the direction cosines of PO bar minus cos alpha, minus cos beta, minus cos gamma are known as direction cosines of the vector PO bar. And we learned that the direction cosines of a line OP are plus or minus cos alpha comma, plus or minus cos beta comma, plus or minus cos gamma are the direction cosines of the line OP. What is the first note point? We learned that cos alpha, cos beta, cos gamma are the direction cosines of a vector OP bar. Then minus cos alpha, minus cos beta, minus cos gamma are the direction cosines of a vector PO bar. What is the second note point? We learned that direction cosines of a vector are denoted by L, M, N. From now onwards, L means cos alpha, M means cos beta, N means cos gamma. And third one, if P equal to x comma y comma z, then direction cosines of a vector OP bar are x divided by root over x square plus y square plus z square, comma y divided by root over x square plus y square plus z square, comma z divided by root over x square plus y square plus z square. And fourth point is the relation between L, M, N. We learned that L square plus M square plus N square value is 1. What we are learning in this class? We are learning about direction cosines and direction ratios. Direction cosine plays the major part. Direction ratios is simple only. So let's see the definition of direction ratios of a vector. The definition of direction ratios of a vector is like this. You consider three numbers which are proportional to direction cosines of a vector. Those three numbers are known as direction ratios of that vector. It is simple only, do not confuse much. Direction ratios of vectors are what? They are three numbers. Three numbers which are proportional to direction cosines of vector, which are known as direction ratios of a vector. Have patience, try to understand coming 5 minutes, then you can understand more clearly about this. I'll take three numbers A, B, C which are proportional to direction cosines L, M, N. See, three numbers A, B, C are proportional to direction cosines L, M, N means what? A divided by L equal to B divided by M equal to C divided by N. This gives, A by L gives some number, na? That number I can take it as K. That means all these are equal to K. From this, what is A? If I equate first one and last one, I'll get A equal to LK. If I equate second one and last one, I'll get B equal to MK. You equate this one and this one, what is C? C equal to NK. You have to observe one thing carefully. What you got? A is LK, B is MK, C is NK. Here very important point is there, listen carefully. We know that A, B, C are the direction ratios of a vector. What I got? I got that LK, MK, NK are the direction ratios of the same vector. If P is x comma y comma z, then what are direction cosines of OP bar? What is L? L is x divided by root over x square plus y square plus z square. Na? What I will do now, I will calculate LK. LK. What is L? L is x divided by root over x square plus y square plus z square. This is what we learn in direction cosines. Now K. K is some scalar. Na? What I will do, you can take K as any scalar. Suppose K as root over x square plus y square plus z square into root over x square plus y square plus z square. Now what happened? These two will get cancelled. What you got? You got LK as x. You got LK as x. Similarly, you will get MK as y. Similarly, you will get NK as z. What you came to know, very important point is there. For the vector, if P equal to x comma y comma z, then for the vector OP bar, x comma y comma z are nothing but the direction ratios. So main important point, if OP bar is xi cap plus yj cap plus z cap, then we can consider their scalar components x, y, z as the direction ratios of that vector, because I taken ABC are the direction ratios. Now what I got ABC values? I got ABC values as x, y, z only. Please keep this point in your mind. From now onwards, for any vector, their scalar components taken as direction ratios of that vector. See here, xi cap plus yj cap plus zk cap is one vector. Now, for this vector, what are the direction ratios? What are their scalar components? X, y, z or the direction ratios of that vector. For this point, you can drop a like for this video. Three numbers a, b, c are proportional to the direction cosines of a vector, then those three numbers are known as direction ratios of that vector. What important point you learn, for every vector, their scalar components acts as a direction ratios. That reason I explained here. And one important point here, A is LK, B is MK, C is NK, like that we got. Na? If I take K is what? K is any scalar. Na? In place of K, if I write 1, L, M, N also acts as direction ratios of that vector. L, M, N also acts as direction ratios of that vector. Important point, direction ratios of a vector are not unique. In next point, you will come to know this point also. For any vector, their direction cosines also acts as the direction ratios. You please observe this note point. If A, B, C are the direction ratios of a vector, three numbers A, B, C are the direction ratios of a vector, then for a non-zero scalar k, you can take any scalar k. K is some constant. For any non-zero scalar k, ka, kb, kc are also direction ratios of that vector. This tells you that direction ratios of a vector are not unique. For example, there is a vector whose direction ratios are 1, 2, 3. Then if I take a non-zero scalar k into 1, k into 2, k into 3 are also direction ratios of that vector. Suppose you take k equal to 2. Multiply all these with 2. What you will get? 2, 4, 6. These are also direction ratios of that vector. So, direction ratios of a vector are not unique. If A, B, C are the direction ratios of a vector, then for any non-zero scalar k, ka, kb, kc are also direction ratios of that vector. I hope you understand this class. If you like this video, please drop a like and share this video with your friends so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Have a great day. Take care. Bye-bye. Hello everyone. I am Balaji Rao. Welcome to BR Maths class. This is 9th class on vector algebra. In last class, we learned about direction cosines and direction ratios of a vector. In case if you not watched earlier classes, I'll give that playlist link in cards here. You can find that link here. In this class, we will learn about section formula in vector algebra. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. In this section formula, total two things are there. One is internal division, another one is external division. In this class, we are going to derive both the results. In two-dimensional geometry, you learn about section formula. I'll quickly recall what you learned in two-dimensional geometry. Let A comma B are any 2 points in a plane and P is a point which divides AB in the ratio m:n. If A equal to x1, y1, B equal to x2, y2, then to calculate the coordinates of P, the formula is mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n. You learned this formula in two-dimensional geometry. This formula is to calculate the coordinates of point P. In vector algebra also, the section formula almost similar. But instead of calculating the point P, I will calculate OP bar. What is OP bar? OP bar is position vector of point P. First, I will write the statement of section formula in internal division. You observe A comma B are 2 points in a space such that OA bar equal to A bar. OA bar means position vector of point A and OB bar equal to B bar. I will draw same information in this figure. You observe here A comma B are 2 points in a space here such that OA bar is A bar, OB bar is B bar. Somewhere origin will be there. So I'll suppose this is the origin O. What I considered, A is a point in a space such that OA bar as A bar. I consider this OA bar as A bar, OB bar, direction you observe, OB bar is B bar. I considered like this. What information is there here? Same thing I written. A comma B are any 2 points in a space such that OA bar equal to A bar, OB bar equal to B bar. And P is a point on AB which divides line segment AB in the ratio m:n internally. P is a point on AB which divides AB in the ratio m:n internally. Internally means the point P is in between A and B. Externally means P is not in between A and B. Let's quickly recall what we consider. A comma B are 2 points in a space such that OA bar equal to A bar and OB bar equal to B bar. And P is a point on AB which divides AB in the ratio m:n internally. Then OP bar means position vector of a point P. Then OP bar is position vector of a point P is MB bar plus NA bar divided by M plus N. What is this? This is the statement of section formula in internal division. Now I am going to derive this result. Why? OP bar is MB bar plus NA bar divided by M plus N. Now I am going to derive this result. You observe this diagram. What is the ratio of AP and PB? What is the ratio of AP and PB? You observe what they given. P divides AB in the ratio m:n. So AP divided by PB is m divided by n. How you came to know this? Because they given that P divides AB in the ratio m:n internally. Now you do the cross multiplication. What you will get? N into AP equal to m into PB. You observe this. This is scalar form. But I want OP bar in vector form. So I need to convert this into vector form. How to convert? You know about equal vectors. When we say two vectors are equal, their direction is same and their magnitudes are equal. Here I will consider two vectors. You observe here I consider two vectors, n into AP bar, m into PB bar. AP bar means it is directed from A to P. PB bar means it is directed from P to B. If you observe this diagram, AP bar, PB bar are in the same direction. You see, this is AP bar, this is AP bar, this is PB bar. AP bar, PB bar are in the same direction. So what is the direction of n into AP bar? The direction of n into AP bar is along the direction of AP bar. What is the direction of m into PB bar? The direction of this vector is along the direction of PB bar. And we came to know that AP bar, PB bar are in the same direction. These are the two vectors which are having same direction. Now I will calculate their magnitude. What is the magnitude of n into AP bar? This is n is a scalar, na? We will write it outside. N into magnitude of AP bar. N into magnitude of AP bar is what? In representation of vectors we learned magnitude of AP bar is AB, magnitude of BC bar is BC, magnitude of AP bar is AP. Okay. Now I will calculate magnitude of this vector also. What is the magnitude of this vector? M is scalar, na? Take that scalar outside. M into magnitude of PB bar. This is what? M into what is magnitude of PB bar? Magnitude of PB bar is PB. Okay. This vector magnitude is n into AP. This vector magnitude is m into PB. Now, as per the given information, I got that these two are equal. I got, you see here, n into AP, m into PB. I got these two are equal. What I came to know here, n into AP bar, comma, m into PB bar. They are in the same direction and these are their magnitudes. Here I got that their magnitudes are equal. Two vectors whose direction is same, whose magnitudes are equal. Then what I can say? I can say that those two vectors are equal. This is in scalar form. What I came to know, these two vectors are equal vectors. N into AP bar equal to m into PB bar. I came to know that this vector and this vector are equal. Why? AP bar, PB bar are in the same direction, and when I calculate their magnitudes as per the given information, their magnitudes are equal. As these two vectors are of same magnitude or in the same direction, I can write equal here. I saw many videos, no one specified about this point. They are directly writing AP bar divided by PB bar is m by n. Actually this side AP bar divided by PB bar is a vector quantity. Here if they write m by n, this is a scalar quantity. We cannot write like that. You can write like this, n into AP bar equal to m into PB bar. Why? Because AP bar, PB bar are in the same direction and their magnitudes are equal, we got from the given information. After this, everything is very easy. In earlier classes, you learned about triangle law of vector addition. There you came to know that AP bar can be written as OB bar minus OA bar. AB bar can be written as OB bar minus OA bar. Similarly, if you saw PQ bar can be written as OQ bar minus OP bar. I explained more clearly in triangle law of vector addition. In case if you not watched that video, that playlist link is there in cards here. Okay. So you see here n. I'll write that n. Okay. Into AP bar. AP bar can be written as OP bar minus OA bar equal to m times of PB bar. PB bar can be written as OB bar minus OP bar. Actually, what I am trying for? I am trying for OP bar. I need to prove that position vector of a point P is MB bar plus NA bar divided by M plus N. So, in the process of simplification of this, I'll try for OP bar. First, I'll multiply this with a scalar. What you will get? N into OP bar minus N into OA bar. I just multiplied this expression with N equal to, similarly multiply this expression with M. What you will get? M into OB bar minus M into OP bar. As I am trying to find OP bar, I'll write all OP bar terms at one side. You take this minus M into OP bar to this side, then what you will get? This minus will become plus M into OP bar here plus N into OP bar equal to, here this side what is remaining? M into OB bar. This minus N into OA bar is there. Now you take it to the right hand side plus N into OA bar. In this you observe here OP bar is there, here OP bar is there. I can take OP bar common. If you take OP bar common, what you will get? You will get that M plus N into OP bar equal to M into OB bar plus N into OA bar. I got like this. Actually what I am trying for? I am trying for OP bar. From this you can easily write OP bar. You take this M plus N to the right hand side. So from this step, what is OP bar? OP bar is M times of OB bar. You observe in the beginning only, what is OB bar? We consider OB bar as B bar. In place of OB bar, I can write B bar plus N into OA bar. You observe here in the beginning only we consider OA bar as A bar. So N into A bar divided by M plus N. So you see we got that OP bar equal to MB bar plus NA bar divided by M plus N. We got this derivation. So you learned the derivation of section formula in internal division. A comma B are any 2 points in a space such that OA bar equal to A bar, OB bar equal to B bar, and P is a point which divides AB in the ratio M is to N internally. Then the position vector of point P, look here, then the position vector of point P, OP bar is MB bar plus NA bar divided by M plus N. So when P divides AB internally, then to calculate OP bar, we will use this formula. Now we will see the derivation of section formula in external division. You observe this is AB And you can observe P is a point on the line AB. You can observe P is not in between A and B. If P is in between A and B, we say that P divides AB internally. Here P is not in between A and B. So here what we say that P divides AB externally. Okay, so if P divides AB externally, then what is the section formula? You observe what is the statement. Let A comma B are any 2 points in a space. I consider 2 points A comma B are any 2 points in a space such that OA bar equal to A bar, OB bar equal to B bar. A comma B are any 2 points in a space such that I take in OA bar as A bar, OB bar as B bar. P is a point on the line AB which divides AB in the ratio M:n externally. We need to understand this meaning carefully. Many students confuse here. External division means which part is M, which part is N. It is very simple. Here P divides AB in the ratio M:n externally means, see this length we'll consider as M and this length we'll consider as N. You observe this length we'll consider as N. Okay, P divides AB in the ratio M:n externally means the length AP is M, the length BP is N. We need to consider like that. Then position vector of a point P formula is MB bar minus NA bar divided by M minus N. If you observe the difference between internal division and external division, in internal division here plus sign is there, in external division we got minus sign. Finally, what I want to prove? I want to prove that position vector of a point P is this. So, position vector of a point P means OP bar. I am trying to calculate OP bar. So, I need to prove that this OP bar is MB bar minus NA bar divided by M minus N. You need to observe one point here. P divides AB in the ratio M:n externally means you need to consider AP divided by BP. AP, M:n. What is M:n? M is AP divided by BP. So, AP divided by BP is M by N. How you got this statement? Because they given P divides AB in the ratio M:n externally they given. From that I got this. Cross multiply, what you will get? N into AP equal to M into BP. Okay, here I got two scalar quantities are equal. You observe here, what is the direction of N into AP bar? N into AP bar is a vector which is along the direction of AP bar. What is the direction of M into BP bar? This is the vector along the direction of BP bar. If you observe the diagram, AP bar, BP bar, AP bar, BP bar are in the same direction. As per the given statement, I got this. I got that their magnitudes are also equal. So I can write that these two vectors are equal. Like same what I explained in internal division. Further, if I simplify this, you know that AP bar can be written as OP bar minus OA bar. Okay, equal to M times of BP bar. BP bar can be written as OP bar minus OB bar. What I am trying for? I am trying for OP bar. Now, in the process of simplification, we will keep that in our mind. We are trying for OP bar. Okay, you multiply this expression with N, what you will get? N into OP bar minus N into OA bar equal to, multiply this quantity with M, what you will get? M into OP bar. Okay, as I am trying for OP bar, I will write all OP bar terms at one side, remaining all other side. Plus N into OP bar, I will take it to the right hand side. Then what you will get? Already here M into OP bar is there. You take this to this side, as it is plus, this will become minus N into OP bar. Okay, now here you observe this minus M into OB bar is there. Now you take it to the left hand side. This minus will become plus M into OB bar minus N into OA bar. As I am trying for OP bar, you take OP bar common here. What you will get? You will get that M minus N into OP bar. This side, what is OB bar? In the beginning only we consider OB bar as B bar. So in place of OB bar, I can write B bar minus N into OA bar. What is OA bar? We consider OA bar as A bar, na? OA bar as A bar. From this step, we can easily write what is OP bar. See here, you take M minus N to the left hand side, then you will get OP bar. So, what is OP bar? OP bar equal to MB bar minus NA bar. divided by, you take m minus n to the left hand side part, what you will get? You will get m minus n. I got that OP bar as mb bar minus na bar divided by m minus n, which is same here, right? So in this class, what you learn? You learn section formula derivations in internal division as well as external division. A comma b are any 2 points in a space such that OA bar equal to A bar, OB bar equal to B bar. P is a point which divides AB in the ratio m:n internally. Then the position vector of a point P, OP bar, is MB bar plus NA bar divided by M plus N. If the point P divides AB in the ratio m:n externally, then OP bar is MB bar minus NA bar divided by M minus N. This is easy derivation only. I hope you understand this class. If you like this video, please drop a like and share this video with your friends without fail so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Have a great day. Take care. Bye-bye. Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 10th class on vector algebra. In this class, we are going to do exercise problems of vector algebra from exercise number 10.2 in NCERT textbook. To do these exercise problems, earlier classes knowledge is needed. In case if you not watched earlier classes, I'll give that playlist link here. You can find that playlist link in cards. Related to second exercise, in theory part, 3 main things are there. One is direction cosines and direction ratios of a vector. Second one is triangle law of vector addition and parallelogram law of vector addition. Third one is section formula in vector algebra. These 3 are the main definitions in the theory part related to second exercise of vector algebra. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. NCERT textbook, class 12, exercise number 10.2 from vector algebra chapter. The first question is like this. Compute the magnitudes of the following vectors. They given 3 vectors, A bar, B bar, C bar. We need to calculate magnitudes of these vectors. In theory part, we learned this point. Magnitude of xi cap plus yj cap plus zk cap is square root of x square plus y square plus z square. So, magnitude of this vector formula is square root of x square plus y square plus z square. First, I will calculate magnitude of vector A bar. You observe they given vector A bar as I cap plus j cap plus k cap. What I need to calculate? I need to calculate its magnitude. I need scalar components of this vector. See, I bar scalar component is 1, j bar scalar component is 1, k bar scalar component is 1. So what is magnitude of this vector? Magnitude of this vector is root over 1 square plus 1 square plus 1 square, right? So what you will get? That is root 3. So magnitude of this vector is root 3. Now you observe the second vector, B bar equal to 2i cap minus 7j cap minus 3k cap. We need to calculate magnitude of this vector. Magnitude of vector. To calculate magnitude of this vector, I need scalar components of this vector. For this vector, scalar components are 2, minus 7, minus 3. So this magnitude is square root of 2 whole square plus minus 7 whole square plus minus 3 whole square. If you simplify this, what we will get? See here, 2 square is 4 plus minus 7 whole square is 49 plus 3 square is 9. Okay, that is root over 49 plus 4, 53 plus 9 is 62. So magnitude of this vector is root over 62. Similarly, what is magnitude of C cap? Magnitude of C cap is square root of, this is the vector C bar na? You take their scalar components 1 by root 3 whole square plus, yes, again 1 by root 3 whole square plus minus 1 by root 3 whole square. If I simplify this further, what I will get? See here, 1 by root 3 whole square is what? 1 by root 3 whole square is 1 by 3. 1 by 3 plus 1 by 3 plus 1 by 3. If I simplify further, 3 is the LCM. In the numerator, you will get 1 plus 1 plus 1. In the numerator, you will get 3. 3 divided by 3 is what? 1. So magnitude of this third vector is 1. And we know that if magnitude of a vector is 1, we will say that that is a unit vector. So this is a unit vector. Calculating magnitude of a vector is important. Throughout this chapter, most of the times we will calculate magnitudes of the given vectors. So to calculate magnitudes of the given vectors, this formula you need to know. You observe this second question. Write two different vectors having same magnitude. This is very easy question, but to answer this, theory part knowledge is compulsory. Here, what they are saying, two different vectors. What do you know about different vectors and equal vectors? Equal vectors means the vectors which are having same magnitude and same direction are known as equal vectors. If they are not having same magnitude or if they are not having same direction, then we will say the vectors are different vectors. I will write an example of two different vectors which are having same magnitude. I will consider a vector like this. A bar equal to I cap plus 2j cap plus 2k cap. I consider a vector A bar like this. What is magnitude of this vector? Magnitude of this vector is root over. What are the scalar components of this vector? 1, 2, 2. So 1 square plus 2 square plus 2 square. So what you will get here, that is root over 1 plus 4 plus 4. This is root 9. Root 9 is same as 3. So I consider a vector whose magnitude is 3 units. Now, what do you know about minus a bar? What do you know about minus a bar? A bar minus a bar are equal vectors? No, their direction is different now. Moreover, the direction of minus a bar is exactly opposite direction of a bar. How you will get minus a bar? Multiply this complete vector with minus. What is minus a bar? Minus a bar is minus I cap minus 2j cap 2k cap. It is 100% clear that a bar minus a bar are different vectors. Now the question is, are these two vectors are having same magnitude or not? For that I will calculate magnitude of this vector. Magnitude of minus a bar. To calculate magnitude of a vector, I need scalar components of this vector. What are scalar components of this vector? Minus 1, minus 2, minus 2. So what you will get? Minus 1 whole square plus minus 2 whole square plus minus 2 whole square. What is minus 1 whole square? As whole square is there, this minus will become plus only. Minus 2 whole square is 4. Minus 2 whole square is 4. Root 9. This is root 9. What is the value of root 9? The value of root 9 is 3. You can observe here, they are having same magnitude. Therefore, a bar comma minus a bar are the different vectors with same magnitude. You observe this question number 3. Write two different vectors having same direction. The vectors are different, having same direction. Okay. To do this, if you have knowledge of scalar multiplication of a vector, you can write this answer very easily. What do you know about a bar, ma bar? In scalar multiplication of a vector, you learn this point, ma bar. If m is positive, what is the direction of ma bar? The direction of ma bar is along the direction of a bar. What I am trying to say here, a bar, ma bar will have same direction when m is positive. You see here, as 2 is positive, 2a bar also along the direction of a bar. So a bar, 2a bar are in the same direction. Not only these vectors, a bar comma 3a bar, they are also in the same direction. A bar comma 1 by 2 into a bar, these are also in the same direction. Like this, we can give infinitely many examples. You observe here, I consider a vector a bar as I cap plus 2j cap plus 3k cap. This contains some direction. What you learned just now, a bar comma 2a bar will be in the same direction. As 2 is positive, a bar comma 2a bar are in the same direction. What is a 2a bar? How you will get this 2a bar? Multiply this complete vector with a scalar 2. Multiply, what you will get? 2 into I cap plus 2 into 2, that is 4 into j cap. Multiply this complete vector with 2 plus 2 into 3, that is 6k cap. You observe here, A bar to A bar, they are in the same direction. Now the question is, their magnitudes are different or not? I'll calculate here. See, magnitude of A bar. What is the magnitude of A bar? Root over. What is magnitude of A bar? What are scalar components of A bar? 1, 2, 3. So what is its magnitude? 1 square plus 2 square plus 3 square. Root over 1 plus 4, that is 5. 5 plus 9, that is 14. So magnitude of A bar is, I got root 14. Now I will calculate magnitude of this vector. Magnitude of 2A bar. We already learned the formula to calculate magnitude of this vector. Modulus of 2 into modulus of A bar. Modulus of 2 is 2 only. 2 root 14. You can observe here, this A bar is a vector whose magnitude is root 14. 2A bar is a vector whose magnitude is 2 times of root 14. Their magnitudes are different and you know that their directions is same. So you observe here, I written A bar comma 2A bar are two different vectors. How you came to know they are different vectors? Because their magnitudes are not same. That's why they are different vectors. What about direction of A bar and 2A bar? We know that their direction is same. Now you observe this question number 4. Find the values of x and y. We need to find the values of x and y. For that, what information given? So that the vectors, here you see they given two vectors. These two vectors are equal. This is very easy question. You see what they given? They given two vectors. They are saying that these two vectors are equal vectors. Then find the values of x and y. You compare the scalar components of these two. You see here I bar component is x. Here I bar component is 2. So what I'll write? I'll write x equal to 2. You observe here j bar component is y. Here j bar component is 3. So I'll write y equal to 3. In this vector, in place of x you write 2, in place of y you write 3. Then what this will become? This is 2i cap plus 3j cap. Then those two are equal vectors. It is very easy to say. So if these two vectors are equal, what are the values of x and y? X is 2, y is 3. Very simple. Okay. You observe this question number 5. Find the scalar and vector components of the vector. Find the scalar and vector components of the vector with initial point 2, 1, terminal point is minus 5, 7. What I'll do here, I'll take initial point as A. I am considering let A is 2, 1. And what is the terminal point? B is minus 5, 7. I consider that initial point is A, terminal point is B. As initial point is A, terminal point is B, first I'll calculate the vector AB bar. AB bar. To calculate AB bar, what is the formula you learned? In triangle of vector addition, you learned this point. AB bar can be written as OB bar minus OA bar. AB bar can be written as OB bar minus OA bar. But they are not given OA bar, OB bar. It's okay. We know that if there is a point, then we can write its position vector. Here the point A is given, then you can write OA bar. What is OA bar? OA bar is 2 into I cap plus 1 into j cap, which is same as j cap. Okay, and as they given point B, you can write OB bar. Every point can be expressed in terms of its position vector. This is point B now. So OB bar can be written as minus 5 I cap plus 7 j cap. Okay, OB bar. What is OB bar? Minus 5 I cap plus 7 j cap minus of OA bar. What is OA bar? 2 I cap plus j cap. Okay, now I will simplify this. Here minus 5 is there, minus 2. Minus 5 minus 2 is what? Minus 7 I cap. It can be understood easily. Now you observe j cap components. Here 7 is there. Here plus of minus is minus. 7 minus 1, that is 6. 6 j cap. So I calculated AB bar. AB bar is OB bar minus OA bar. So what is this vector? This vector is AB bar. Now what they are asking? Scalar components of vector AB bar. Scalar components of vector AB bar. See here I got AB bar as minus 7 I cap plus 6 j cap. Now what are its scalar components? Its scalar components are minus 7, 6. These are the scalar components of the vector AB bar. Vector components of the vector AB bar. What are vector components of this vector AB bar? Minus 7 I cap comma 6 j cap. These are known as vector components of the vector AB bar. These are known as scalar components of the vector AB bar. You see this question number 6. This is very easy question. Find the sum of the vectors. They given A bar, B bar, C bar. They are asking to calculate sum of these three vectors. Sum of these three vectors A bar, B bar, C bar is denoted like this: A bar plus B bar plus C bar. To calculate sum of these three vectors, just I will consider scalar components of A bar, B bar, C bar. You observe here I bar coefficient is 1. Here I bar coefficient is -2. Here I bar coefficient is 1. I'll add these numbers. Okay, what you will get? 1. I bar coefficient is 1 plus here I bar coefficient is -2 plus here I bar coefficient is 1 into I cap plus. Now J bar coefficients. What is J bar coefficient here? J bar coefficient is -2 plus here J bar coefficient is 4 plus here J bar coefficient is -6. Okay, into J cap plus. Now you observe here what is K cap coefficient, that is 1 plus here K cap coefficient 5 plus here K cap coefficient -7 into K cap. Okay, you observe this 1 plus 1 is 2, 2 minus 2 is 0, 0 into I cap plus. You observe this -2 plus 4, that is +2 plus 2 minus 6 is -4 into J cap plus. 1 plus 5 is 6, 6 minus 7 is -1 into K cap. 0 into I cap, this is nothing but 0 only. So what you will get here? -4 into J cap minus K cap. Therefore, addition of these three vectors is -4 J cap minus K cap. I hope you understand this class. If you like this video, please drop a like for this video and share this video with your friends so that they also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye. Hello everyone. I am Balaji Rao. Welcome to BR Max class. In last class, I did 6 problems in exercise number 10.2 vector algebra. In this class, I am going to do another 4 problems from question number 7 to question number 10. Whatever the problems I will discuss in this class, they are all related to unit vector. It is important to know the definition of unit vector. In case if you not watched my video on definition of unit vector, that video link I'll give in cards here. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You see this question number 7, what they are asking. Find the unit vector in the direction of A bar. They given vector A bar. In this question, 2 things you need to observe. First one, unit vector, and that unit vector is in the direction of this vector A bar. While learning the definition of unit vector, you learn this point. A bar divided by magnitude of A bar is a unit vector in the direction of A bar. This I clearly discussed in the definition of unit vector. A bar divided by magnitude of A bar. What it is? It is a unit vector along the direction of A bar. Similarly, if you want to find a unit vector along the direction of B bar, what to calculate? You need to calculate B bar divided by magnitude of B bar. What is this? This is the unit vector in the direction of B bar. In case if you want to find unit vector in the direction of AB bar, what to calculate? You need to calculate AB bar divided by magnitude of AB bar. What is this AB bar divided by magnitude of AB bar? It is a unit vector in the direction of AB bar. This is the point we learned while learning the definition of unit vector. Now, to calculate unit vector in the direction of A bar, I need these 2 things. Here, A bar already given. Magnitude of A bar is needed. So, first I will calculate magnitude of A bar. They given A bar. A bar is given as I cap plus J cap plus 2K cap. To calculate magnitude of this vector, I need scalar components of this vector. What are the scalar components of this vector? 1, 1, 2. So magnitude of this vector is what? Square root of 1 whole square plus 1 whole square plus 2 whole square. That equal to root over 1 plus 1 plus 4. That equal to root 6. I got magnitude of a bar as root 6. Now I know the formula for unit vector along the direction of a bar. What is the formula to calculate unit vector along the direction of a bar? A bar divided by magnitude of a bar. Same thing I'll write here. Unit vector in the direction of a bar formula is a bar divided by magnitude of a bar. A bar they already given in the question. What is a bar? A bar is I cap plus j cap plus 2k cap divided by magnitude of a bar. I got that magnitude of a bar as root 6. So what I'll write here, this I can write it as 1 by root 6 into I cap plus j cap plus 2k cap. This vector simply I can write like this. What is this? This is the unit vector along the direction of a bar. I hope you understand this solution. Now we will move to next question. You observe this question number 8. What they are asking? Find the unit vector in the direction of PQ bar. We need to find unit vector in the direction of PQ bar. This problem is similar to earlier problem. To calculate this, what they given? They given the point P and they given point Q. First thing, what is the unit vector in the direction of PQ bar? The unit vector in the direction of PQ bar is PQ bar divided by magnitude of PQ bar. This is the formula to calculate unit vector in the direction of PQ bar. Okay, to calculate this, I need PQ bar, I need magnitude of PQ bar. But if you observe the question, they given just the points P and Q. They not given PQ bar, they not given modulus of PQ bar. So first I'll calculate PQ bar and its magnitude to write this formula. First I'll write given information. They given the points P and Q. What I need to calculate? I need to calculate PQ bar. What is the formula to calculate PQ bar? In triangle law of vector addition, we learned this formula. AB bar, the vector AB bar can be written as OB bar minus OA bar. Similarly, the vector PQ bar can be written as OQ bar minus OP bar. So, what is the formula for PQ bar? The formula for PQ bar is OQ bar minus OP bar. So, to calculate PQ bar, if you know OQ bar, OP bar, it is enough. But in the question, OP bar, OQ bar not given. But we know that every point can be expressed in terms of its position vector. While learning the theory part, you learn this point. If the point P equal to x comma y comma z, then OP bar can be written as xi cap plus yj cap plus zk cap. Similarly, as they given the point P, you can write OP bar. What is OP bar? I cap plus 2 into j cap plus 3 into k cap. As they given point Q, you can write OQ bar. Position vector of point Q is what? 4 into I cap plus 5 into j cap plus 6 into k cap. When they given a point P, then easily we can write its position vector. Every point can be expressed in terms of its position vector. So now I have OP bar, OQ bar. This is the formula to calculate unit vector in the direction of PQ bar. So I need PQ bar. What is the formula for PQ bar? The formula for PQ bar is OQ bar minus OP bar. Okay. Now subtract these two vectors. 4 minus 1, that is 3 into I cap, plus 5 minus 2, that is 3 into j cap, plus 6 minus 3, that is 3 into k cap. You observe, I got the vector PQ bar. Now this is the formula. Na? In this formula, I need magnitude of PQ bar also. So I'll calculate magnitude of PQ bar. What is magnitude of PQ bar? To calculate magnitude of PQ bar, I need their scalar components. And what is the formula? Root over. What are the scalar components of this vector? 3, 3, 3. So 3 whole square plus 3 whole square plus 3 whole square. Okay. What is this? This is 3 times of 3 whole square. 3 whole square is what? 3 whole square is 9. If I simplify this, this is root 3 into root 9. Root 9 value is 3 na? So if you simplify this, you will get 3 into root 3. I need to calculate unit vector in the direction of PQ bar. I know that formula is PQ bar divided by magnitude of PQ bar. Now I have PQ bar and I have magnitude of PQ bar also. Now directly I'll write the formula. Unit vector in the direction of PQ bar. What is the formula? The formula is PQ bar divided by magnitude of PQ bar. Okay. What is PQ bar? You observe here. This is PQ bar. In this PQ bar, here 3 is there, here 3 is there, here also 3 is there. So I can take 3 common. Take 3 common. This PQ bar can be written as 3 into I cap plus j cap plus k cap whole divided by magnitude of PQ bar. What you got? Magnitude of PQ bar as 3 into root 3. Now what happens? This 3 will get cancel. This is over. I calculated unit vector in the direction of PQ bar. If you want to simplify, one more small simplification step you can write. This whole divided by root 3 can be written as 1 by root 3 into I cap plus j cap plus k cap. What is this? This is the unit vector in the direction of PQ bar. I hope you understand solution for this problem. Now we will move to next question. You observe this question number 9. What they are asking? For the given vectors a bar, b bar, they given two vectors a bar, b bar. For these two given vectors, what they are asking? Find the unit vector in the direction of a bar plus b bar. You observe this is also similar to last problem. Unit vector in what direction? In the direction of a bar plus b bar. What is the formula to calculate unit vector in the direction of a bar plus b bar? The formula is a bar plus b bar divided by magnitude of a bar plus b bar. What is this? This is the formula to calculate unit vector in the direction of a bar plus b bar. To calculate this, first I need a bar plus b bar and I need magnitude of a bar plus b bar. As they given the vectors a bar, b bar, I can easily calculate a bar plus b bar and its magnitude. So to calculate unit vector in the direction of a bar plus b bar, first I will calculate a bar plus b bar. I written given vectors a bar and b bar. Now I need to calculate a bar plus b bar. Calculate a bar plus b bar. You just add these two vectors. You observe here 2 plus of minus 1, that is 1. 1 into I cap, 1 into I cap plus minus 1 plus 1. Minus 1 plus 1 is 0. 0 into j cap plus 2 plus of minus 1, that is 1 into k cap. If I simplify this, 1 into I cap is nothing but I cap. This is 0 plus 1 into k cap is nothing but k cap. So when I calculate a bar plus b bar, I got I cap plus j cap. Now I need magnitude of a bar plus b bar. Magnitude of this vector a bar plus b bar. To calculate magnitude of the vector a bar plus b bar, I need scalar components of a bar plus b bar. What are the scalar components of a bar plus b bar? You see here 1, 1. So what you will get here? 1 square plus 1 square, that is root 2. Okay. Now I know what is a bar plus b bar. I know magnitude of a bar plus b bar. Now I can easily write. What is the formula to calculate unit vector in the direction of a bar plus b bar? This is the formula. I'll write the same thing. So unit vector in the direction of a bar plus b bar is a bar plus b bar divided by magnitude of a bar plus b bar. Magnitude of a bar plus b bar is root 2 and a bar plus b bar is I cap plus j cap. Na? So what this can be written as? This can be written as 1 by root 2 into what is a bar plus b bar, that is I cap plus j cap. So this is the unit vector in the direction of a bar plus b bar. I hope you understand this. Now we will move to next question. That is also based on unit vector only. You observe this question. Many students, they feel difficult to understand this question number 10. Actually, it is very easy. First, you try to understand what they are asking in the question. Find a vector in the direction of this vector. You observe they are not specifying it is a unit vector. Find a vector which is in this direction, and whatever the vector you are finding, that vector magnitude is 8 units. You need to find a vector whose direction is along this vector and whose magnitude is 8 units. First, I will consider given vector as a bar. First, I considered given vector as a bar. This vector magnitude is 8 units. I need to check first. First, I'll check given vector magnitude is 8 units or not. To calculate magnitude of this vector, I need scalar components of this vector. What are scalar components of this vector? 5, -1, 2. So what is its magnitude? Square root of 5 whole square plus -1 whole square plus 2 whole square. If I simplify this, what I will get? 25 plus 1 plus 4. This is 25 plus 5, that is 30. So magnitude of given vector is root 30. Its magnitude is not 8 units. Okay, one thing is clear. Given vector magnitude is root 30. What you want to calculate? You need to find a vector. You need to find a vector in the direction of a bar. Here I'll explain few things. Please you understand this. Later we'll continue the solution. You taken this vector as a bar, na? What do you know about a bar divided by magnitude of a bar? It is a unit vector. Last 3 problems we did that only now. A bar divided by magnitude of a bar is a unit vector along the direction of a bar. This is the unit vector. That means its magnitude is 1 and the direction of this vector is along the direction of a bar. Now what I'll do, I'll multiply this vector with 8. Let's see what happened. 8 into a bar divided by magnitude of a bar is a vector along the direction of a bar. This is the vector along the direction of given vector. I taken this vector as a bar now. And what is magnitude of this vector? When I calculate its magnitude, you see, when I calculate its magnitude, you know this formula. Magnitude of m a bar formula is what? M into magnitude of a bar when m is positive. So this can be written as 8 into magnitude of a bar divided by magnitude of a bar. You know that a bar divided by magnitude of a bar is a unit vector. So magnitude of a bar divided by magnitude of a bar is what? Is 1. So you will get 8. So you can observe here. This is a vector along the direction of a bar and whose magnitude is 8 units. What is the vector in the direction of this vector whose magnitude is 8 units? That is 8 into a bar divided by magnitude of a bar. This is the vector whose magnitude is 8 units and the direction of this vector is along the direction of a bar. So as I taken given vector as a bar, now I will try to calculate this. You observe what I written. 8 into a bar divided by magnitude of a bar is a vector. What is the direction of this vector? Along the direction of a bar with magnitude 8 units. With magnitude 8 units. So now I will calculate this vector. 8 into a bar divided by magnitude of a bar. 8 into, what is a bar? A bar is 5i cap minus j cap plus 2k cap divided by magnitude of a bar. What is magnitude of a bar? Magnitude of a bar is root 30. So this is the vector along the direction of given vector and whose magnitude is 8 units. If you want, you can do little bit of simplification. What is that little bit of simplification? This complete vector you multiply with 8. 8 into 5, that is 40 I cap minus 8 j cap plus 8 2s are 16 k cap whole divided by root 30. This is the required answer. These problems are very easy if you are good in the concept. I hope you understand these problems with the help of concept. If you like this video, please drop a like for this video and share this video with your friends so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Have a great day. Take care. Bye-bye. Hello everyone. I am Balaji Rao. Welcome to BR Max class. Till now, we completed 10 problems in exercise number 10.2 from vector algebra chapter. In case if you not watched earlier classes in this vector algebra chapter, I'll give that playlist link in cards here. In this class, I'm going to do from question number 11 to question number 14. We will do 4 problems in this class. One problem is related to collinear vectors and remaining 3 problems are related to direction cosines of a vector. To understand this class very easily, if you know the definition of collinear vectors and direction cosines of a vector, then you can do these problems very easily. So before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You observe this question number 11. What they are asking, show that these two vectors are collinear. We need to show that these two vectors are collinear vectors. While learning the definition of collinear vectors, you learn this point. If one vector is expressed as scalar multiple of other vector, then we say that those two vectors are collinear vectors. Collinear vectors are also known as parallel vectors. You learn this point. If a vector a bar equal to lambda times of b bar, or the vector b bar equal to lambda times of a bar, then we say the vectors a bar comma b bar are collinear vectors. What I'll try to do now in these two vectors, I'll try to check, is it possible to express one vector as scalar multiple of other vector or not. If you observe this vector, observe the scalar components of this vector, minus 4, 6, minus 8. It seems to be I can take two common in this. So first I'll take this vector. First I consider this vector. What I am trying for? I am trying to express one vector as scalar multiple of other. So what I'll do here in this vector, I'll take minus 2 common. Take minus 2 common. What you will get? Minus 2 if you take common, this is a 2 I cap. You observe when you multiply these two, you will get minus 4 I cap. Here plus 6 is there. As you take in minus common, this will become minus 3j cap. So if you multiply minus 2 into minus 3j, you will get plus 6j cap only. Here minus 8 is there. So to get that, I'll write here plus 4k cap. You observe whatever I got here, this vector is same as this vector. So what happened? One vector is expressed as scalar multiple of other vector. If I suppose this vector as a bar, so I got that this vector is scalar. This is scalar here. Scalar multiple of another vector. If you suppose this vector as b bar, you can identify that I got that one vector is a scalar multiple of another vector. From this, I can say that given vectors are collinear vectors. This is very easy question. Therefore, given vectors are collinear vectors. Now, we are going to do another 3 problems in this class. All those 3 problems are related to direction cosines of a vector. You observe this question number 12. What to calculate? Find the direction cosines of this vector. You learn the formula for direction cosines of a vector. I'll write that formula here. You observe this. You learn this formula. Direction cosines of a vector xi cap plus yj cap plus zk cap is x divided by square root of x square plus y square plus z square comma y divided by square root of x square plus y square plus z square comma z divided by square root of x square plus y square plus z square. This is the formula you learned while learning the definition of direction cosines of a vector. Here what to find? We need to find direction cosines of this vector. First I'll write that given vector. What is the given vector? I cap plus 2j cap plus 3k cap. Okay, now if you observe, in place of x here 1 is there, in place of y here 2 is there, in place of z here 3 is there. So I'll substitute x is 1, y is 2, z is 3 in this formula to get this answer. What is x? X is 1. 1 divided by square root of x square plus y square plus z square, that is 1 square plus 2 square plus 3 square comma y. What is y? Y is 2. 2 divided by square root of x square plus y square plus z square comma z. What is z? Z is 3. 3 divided by root over x square plus y square plus z square. Okay, if I simplify this, what I'll get? 1 divided by 1 plus 4, 5. 5 plus 9, 14. So this is root 14. 1 by root 14, comma 2 divided by root 14, comma 3 divided by root 14. So if the given vector is I cap plus 2j cap plus 3k cap, then direction cosines of this vector are 1 by root 14 comma 2 by root 14 comma 3 by root 14. I hope you understand. You can do this problem very easily. Only the thing is you need to know this formula. This is the formula to calculate direction cosines of a vector xi cap plus yj cap plus zk cap. Now we will move to next question that is also related to direction cosines of a vector. You observe this question number 13. What they are asking in this question number 13? Find the direction cosines of a vector joining the points A and B. We need to find direction cosines of a vector joining the points A and B directed from A to B. We need to find direction cosines of a vector joining from A to B which is directed from A to B. That means I need to calculate direction cosines of a vector AB bar A to B. I need to find direction cosines of a vector AB bar. Here in the question directly they specified what is AB bar. They not given. We need to calculate the vector AB bar. To calculate AB bar, we know the formula. What is the formula to calculate AB bar? AB bar can be written as OB bar minus OA bar. But in the question, they given OB bar, OA bar? No, it's okay. But they given the points A and B. We know that every point can be expressed in terms of its position vector. In last class also we discussed this. If the point A is 1, 2, minus 3, then from this we can write OA bar. What is OA bar? OA bar is I cap plus 2j cap minus 3k cap. Similarly, if you know the point B, as they given point B as minus 1, minus 2, 1, from this you can write OB bar. What is OB bar? OB bar is minus I cap minus 2j cap plus k cap. This we already learned in earlier classes also. What we need to find? We need to find direction cosines of a vector AB bar. For that, I need the vector AB bar. I know the formula to calculate the vector AB bar. What is the formula for AB bar? The formula for AB bar is OB bar minus OA bar. Okay, what is OB bar? OB bar is minus I cap minus 2j cap plus k cap. This is OB bar minus OA bar. What is OA bar? OA bar is I cap plus 2j cap minus 3k cap. Now subtract these two vectors. What you will get? Minus 1, that is minus 2 I cap minus 2, that is minus 4 j cap plus 1 minus of minus plus 1 plus 3, that is plus 4 k cap. I got the vector AB bar. What is the vector AB bar? Minus 2 I cap minus 4 j cap plus 4 k cap. So now I know the vector AB bar. To calculate direction cosines of this vector, this is the formula. Okay, direction cosines of AB bar equal to x. What is x? X is minus 2 divided by root over x square, that is minus 2 whole square plus y square, that is minus 4 whole square plus z square, that is 4 whole square. Okay, comma y. What is y? Y is minus 4 divided by root over minus 2 whole square plus minus 4 whole square plus 4 whole square, comma what is z? Z is 4 divided by root over minus 2 whole square plus minus 4 whole square plus 4 whole square. In this formula, in place of xyz, I substituted minus 2, minus 4, 4 respectively to get this. Okay, if I simplify this further, what I'll get? Minus 2 divided by minus 2 whole square is 4. Minus 4 whole square is 16. 4 plus 16 is 20. 20 plus 16, that is 36. Root 36 is what? Root 36 is 6. Okay, so here what you will get? Minus 4 divided by, this is 36. Root 36 is 6. Okay, 4 divided by 6. You can stop this here or you can simplify little bit if you want. 2 table in this 3 times. Here 2 table 2 times, 2 table 3 times, 2 table 2 times, 2 table 3 times. So what you will get? You will get minus 1 by 3, comma minus 2 by 3, comma 2 by 3. So these are the direction cosines of the vector AB bar. I hope you understand this. This is easy only. You observe this question number 14, what they are asking. Show that the vector, this is the given vector. We need to show that this vector is equally inclined to OX, OY, OZ. Here OX is positive x-axis, OY is positive y-axis, OZ is positive z-axis. In this question what they are asking, this vector is equally inclined to OX, OY, OZ. It means that we need to show that this vector makes equal angles with OX, OY, OZ. To prove that this vector makes equal angles with OX, OY, OZ, I will calculate direction cosines of given vector first. Later we will discuss that this vector is equally inclined with coordinate axis or not. First find direction cosines of this vector. The given vector is I cap plus j cap plus k cap. We know the formula for direction cosines of a vector. What is the formula for direction cosines of a vector? This is the formula to calculate direction cosines of a vector. Here in place of x I'll write 1, in place of y I'll write 1, in place of z I'll write 1 because the scalar components of this vector are 1, 1, 1. Okay. So substitute this x, y, z values in this formula. X value is 1 divided by root over 1 square plus 1 square plus 1 square, comma. Y value is also 1 divided by root over 1 square plus 1 square plus 1 square. Z value is also 1 divided by root over x square plus y square plus z square. If I simplify this, what I will get? 1 divided by root 3, comma 1 divided by root 3, comma 1 divided by root 3. What are these? These are the direction cosines of given vector. What is the definition of direction cosines of given vector? If a vector makes an angle alpha with x-axis, makes an angle beta with y-axis, makes an angle gamma with z-axis, then cos alpha comma cos beta comma cos gamma are called direction cosines of that vector. That means whatever you got here, this is cos alpha, this is cos beta, this is cos gamma. You observe here, what is cos alpha? Cos alpha is 1 by root 3. As you got cos alpha here, I can write alpha. What is alpha? Alpha is the angle made by this vector with x-axis. I got alpha as cos inverse of 1 by root 3. Okay. Now what is this? This is cos beta. What is cos beta we got? Cos beta we got it as 1 by root 3. From this we can write beta. What is beta? Beta is cos inverse of 1 by root 3. What is beta? Beta is the angle made by this vector with y-axis. I got beta as cos inverse of 1 by root 3. You see here also cos inverse of 1 by root 3, here also cos inverse of 1 by root 3. Okay. And what is cos gamma? We got that cos gamma is 1 by root 3. From this what is gamma? Gamma is cos inverse of 1 by root 3. So here I got alpha, beta, gamma. From the definitions of direction cosines of a vector, we know that alpha is the angle made by this vector with x-axis, beta is the angle made by this vector with x-axis, gamma is the angle made by this vector with z-axis. You can identify that alpha value, beta value, gamma value we got same. That means by seeing these three things, we can say that alpha is same as beta is same as gamma. These three angles are equal. That means what it concludes? It concludes that a given vector makes equal angles with the x-axis, y-axis, z-axis. So therefore, given vector is equally inclined to OX, OY, OZ. I hope you understand this. Problems in vector algebra are very easy. You can enjoy this chapter only when you are good in the theory part. If you like this video, please drop a like for this video and share this video with your friends so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye bye. Hello everyone. I am Balaji Rao. Welcome to BR Max class. Till now, we completed 14 problems in exercise number 10.2 from vector algebra chapter. In case if you not watched earlier classes in vector algebra chapter, I'll give that playlist link in cards here. In this class, we are going to do total 5 problems. In that, first 2 problems based on section formula. Next 2 problems on triangle law of vector addition. Last problem is on collinear vectors definition. You can understand this class very easily if you know about the definition of section formula and triangle of vector addition and the definition of collinear vectors. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. You observe this question number 15, it is based on section formula. What they are asking in the question? Find the position vector of a point R. Position vector of a point R is denoted by OR bar. So we need to calculate OR bar. And the point R divides the line segment joining the points P and Q in the ratio 2:1. The point P divides in the ratio 2:1 internally as well as externally. Both the things we need to do. What they are asking? Position vector of a point R. What is R? R divides PQ in the ratio 2:1 internally, that is bit number 1. And the point R divides PQ in the ratio 2:1 externally, that is second bit. To calculate OR bar, what information they given? You see here, this is position vector of point P, that means this is OP bar. This is position vector of point Q, that means this is OQ bar. To calculate OR bar, they given OP bar and they given OQ bar. Okay, I'll quickly recall what you learned in the definition of section formula. P is a point on the line segment AB which divides AB in the ratio m:n internally such that OA bar is A bar, OB bar is B bar. Then the position vector of point P, OP bar. To calculate OP bar, we learned the formula MB bar plus NA bar divided by M plus N. This is the formula to calculate position vector of a point P. Now, the same thing we'll apply to this question. What they are asking in the question? Find the position vector of a point R which divides line segment PQ. Here, in place of P, R is there. R is a point which divides PQ. That means this is P, this is Q, which divides PQ in the ratio 2:1, which divides PQ in the ratio 2:1 internally. As the point R is in between P and Q, R divides PQ in the ratio 2:1 internally. Then we need to calculate position vector of a point R. That means we need to calculate OR bar. We'll start the solution. First, what is the given information? They given position vectors of point P and Q. That means they given OP bar and they given OQ bar. What is OP bar? OP bar is I cap plus 2j cap minus k cap. That is OP bar. What is this? This is OQ bar. What is OQ bar? Minus I cap plus j cap plus k cap. I'll do the first bit in this. What is the first bit? The point R divides line segment PQ in the ratio 2:1 internally. You observe this point. What is the point I written? R is a point which divides PQ in the ratio 2:1 internally. Then to calculate position vector of point R, what is the formula? You see, this is the formula we learn in section formula. MB bar plus NA bar divided by M plus N. Here m:n means what they given? Here they given ratio is 2:1. That means this is the ratio of m:n. Okay, here OP bar is nothing but A bar, OQ bar is nothing but B bar. So if I apply the formula MB bar, M is what? M is 2. B bar is what? B bar is OQ bar plus N. What is N? 1 into A bar. What is A bar here? A bar is OP bar. MB bar plus NA bar divided by M plus N. What is M plus N? M plus N is 2 plus 1. Okay. Now I need to calculate 2 into OQ bar. OQ bar already is there na? 2 into OQ bar means you multiply this complete vector with 2. Multiply this complete vector with 2. Minus 2i cap plus 2j cap plus 2k cap plus 1 into OP bar. 1 into OP bar is same as OP bar only. What is OP bar? OP bar is given as I cap plus 2j cap minus k cap whole divided by 1 plus 2. 1 plus 2 is 3. Now I'll do little bit of simplification. I'll add these two vectors. If I add these two vectors, what I'll get? You observe I bar components here 2 is there, here 1 is there. 2 plus 1 is 3. 3 I cap plus 2 plus 2 is 4 j cap plus 2 minus 1. Plus 2 minus 1, that is plus 1 only. Plus k cap divided by 3. What is this? This is OR bar. In the question, what they are asking? Position vector of point R. Position vector of point R means what? OR bar only na? When the point R divides PQ in the ratio 2:1 internally, then the position vector of OR bar is this. I hope you understand this. This is easy only. Now second bit. What is the second bit? Same question. R divides PQ in the ratio 2:1 externally. Then we need to calculate position vector of point R. R divides PQ in the ratio 2:1 externally. It means that R is not in between P and Q. You observe here, this is PQ. R is not in between P and Q, but R is on PQ. So, if the point R divides the line segment PQ in the ratio 2:1 externally, then to calculate position vector of point R, the formula is MB bar minus NA bar divided by M minus N. You see here what I written? R is a point which divides PQ in the ratio 2:1 externally. When it divides externally, what is the formula? MB bar. Here B bar means OQ bar minus internal division, external division, only difference is minus. MB bar minus NA bar. A bar means OP bar divided by M minus N. This is the formula to calculate OR bar in external division. Okay. Now 2 into OQ bar. This OQ bar is there na? Multiply this complete OQ bar with 2. Then you will get 2 into OQ bar. Multiply with 2. What you will get? Minus 2 I cap plus 2 J cap plus 2 K cap minus 1 into OP bar is nothing but OP bar only. What is OP bar? I cap plus 2 J cap minus K cap divided by 2 minus 1. 2 minus 1 is 1 only. Little bit of simplification. I will subtract these two vectors. You observe I bar components. Minus 2 minus 1, that is minus 3. Minus 3 I cap. 2 minus 2, that is 0. Okay, 0 into J cap, no need to write, that will become 0. 2 minus of minus plus 1. 2 plus 1 is 3 plus 3 K cap. So I got minus 3 I cap plus 3 K cap. What is this? This is position vector of point R, OR bar. What they are asking? Find the position vector of a point R. That means we need to calculate OR bar. I hope you understand this. Now we'll move to next question. You observe this question number 16. What they are asking? The position vector of midpoint of the line joining these 2 points. I'll suppose R is the midpoint of line joining the points P and Q. You observe what I written first step. Let R is the midpoint of line joining P and Q. If R is the midpoint of line joining P and Q, then R divides PQ in what ratio? R divides PQ in the ratio 1:1. R is the midpoint of PQ means R divides PQ internally. So you can identify what they are asking in the question. Position vector of the midpoint. If R is the midpoint, position vector of the midpoint R means we need to calculate OR bar. To calculate OR bar, what is the formula? MB bar. Here M is to N means 1:1 only. MB bar. M is 1. B bar means OQ bar. MB bar plus NA bar. A bar means OP bar divided by M plus N. 1 plus 1. Okay. If I simplify this, 1 into OQ bar is OQ bar plus 1 into OP bar is OP bar divided by 1 plus 1 is 2. I need OQ bar, OP bar, but in the question only the points P and Q are given. It's okay. We know that every point can be expressed in terms of its position vector. If you know the point P, you can write OP bar. What is OP bar? OP bar is 2 I cap plus 3 J cap plus 4 K cap. Similarly, as the given point Q, we can write OQ bar. What is OQ bar? 4 I cap plus J cap minus 2 K cap. What is OQ bar? OQ bar is 4 I cap plus J cap minus 2 K cap plus OP bar. What is OP bar? OP bar is 2 I cap plus 3 J cap plus 4 K cap whole divided by 2. We'll simplify this. Addition of these two vectors. You see here 4 plus 2. 4 plus 2 is 6. 6 I cap plus 1 plus 3, that is 4 J cap, minus 2 plus 4, that is plus 2 K cap whole divided by 2. You can observe here I can take 2 common in the numerator. If I take 2 common, that will get cancelled in the denominator. Then what you will get? 3i cap plus 2j cap plus k cap. What is this? This is position vector of midpoint of line joining the points P and Q. I hope you understand this. You observe this question number 17. They are asking to show that the points ABC form the vertices of a right angle triangle. We need to show that these 3 points ABC forms the right angle triangle. For that, what information they given? The points ABC with position vectors. You observe what are these 3 vectors? These are the position vectors of given points. Position vector of point A, that means this is OA bar, this is OB bar, this is OC bar. They given OA bar, OB bar, OC bar. They are asking to prove that the vertices A comma B comma C forms a right angle triangle. As they are saying vertices forms a right angle triangle, the basic idea is we will use Pythagoras theorem. Square of hypotenuse is sum of squares of other 2 sides. If we prove that, I can say that the given vertices forms a right angled triangle. Let's see how we solve this problem. In the question only they are saying the position vector of point A is this one. When you know position vector of point A, then you can write that point. Here OA bar is given now. From that we can write point A. What is point A? 3 comma minus 4 comma minus 4. Now I have 3 vertices ABC with their position vectors OA bar, OB bar, OC bar. To prove 3 vertices forms a right angle triangle, I am going to use Pythagoras theorem. To check Pythagoras theorem, we need sides of a triangle ABC. That means I need to calculate the length AB, the length BC, the length CA. To calculate those lengths, first I will calculate the vectors AB bar, BC bar, CA bar. AB bar. How to calculate the vector AB bar? What is the formula to calculate AB bar? We are using this formula very frequently. AB bar formula is OB bar minus OA bar. AB bar can be written as OB bar minus OA bar. See here, subtract these 2 vectors OB bar minus OA bar. See here, 2 minus 3. That 2 minus 3, that is minus 1, that is minus I cap plus minus 1 minus of minus plus 4. Minus 1 plus 4 is 3 into j cap plus 1 minus of minus 4, that is plus 4. 1 plus 4 is 5 into k cap. So I got the vector AB bar. When you know the vector AB bar, then you can calculate its magnitude. What is the magnitude of a vector AB bar? Magnitude of a vector AB bar is AB. AB. We know from the beginning of this chapter we are calculating magnitudes of the vector. This is the vector AB bar. Now what is its magnitude? Its magnitude is AB. To calculate AB, what is the formula? Square root of. Here I bar component is minus 1. Minus 1 whole square plus 3 whole square plus 5 whole square. Okay, that equal to what you will get if you simplify this. Minus 1 whole square is 1. 3 square is 9. 9 plus 1 is 10. 10 plus 25 is 35. So I got length AB as root 35. Similarly, I will calculate BC bar and BC, CA bar and CA. BC bar. To calculate BC bar, what is the formula? BC bar formula is OC bar minus OB bar. Okay, this vector minus this vector. Okay, subtract. You see here 1 minus 2, that is minus I cap plus minus 3 minus of minus 1 plus 1, minus 3 plus 1, that is minus 2 j cap plus minus 5 minus 1, that is minus 6 k cap. You observe here I got the vector BC bar. Now I will calculate their magnitude. Magnitude of BC bar is what? That is BC. BC equal to root over. This is the vector BC bar na? So to calculate its magnitude, what is the formula? Root over minus 1 whole square plus minus 2 whole square plus minus 6 whole square. If we simplify this, what you will get? 1 plus 4, that is 5. 5 plus 36, that is 41. So you got BC as root 41. Similarly, I will calculate CA bar. What is CA bar formula? CA bar formula is OA bar minus OC bar. Okay, OA bar minus OC bar. You subtract these 2 vectors. 3 minus 1, that is 2 I cap, minus 4 minus of minus 3, that is plus 3. So minus 4 plus 3 is minus 1, minus j cap, minus 4 minus of minus 5 plus 5. Minus 4 plus 5 is plus k cap. Now I got the vector CA bar. I will calculate its magnitude. Magnitude of CA bar is CA. What is the formula? 2 whole square plus minus 1 whole square plus 1 whole square. If I simplify this, what I will get? 4 plus 1 plus 1, that is 6. You observe, I got three sides of a triangle AB, BC, CA. I'll check that square of any one side is sum of squares of other two sides. I'll check. What is square of this? BC square is 41. Sum of squares of these two. If I square these two things, square root will get cancelled. 35 plus 6 is 41. So you observe BC square. What is BC square? BC square is 41. BC square is AB square. AB square is 35 plus CA square is 6. It can be understood that these three numbers satisfies this condition. This is what? This is Pythagoras theorem. Pythagoras theorem holds good. It means that given vertices forms a right angle triangle. Therefore, given vertices forms a right angle triangle. Now, you observe this. In triangle ABC, which of the following is not true? Many students, they don't read the question properly. Which of the following is not true? Which one is not true? That is the right option. First, you see this first bit, whether it is correct or not. AB bar plus BC bar. You observe the terminal point of first vector, initial point of second vector is same. So, AB bar plus BC bar is what? Is AC bar. This what you learned in triangle of vector addition. AB bar plus BC bar can be written as AC bar. AC bar plus CA bar. You observe this AC bar plus CA bar. Here also terminal point of first vector, initial point of second vector is same. What is AC bar plus CA bar? This is AA bar. You know that zero vector is denoted by AA bar, BB bar, CC bar. They are all the zero vectors. So here AA bar is zero vector. That means why? Because the initial point and terminal point of the vector coincide. So I got, when I simplify this first option, I got zero vector. That means this is true only. Now I'll check this second one, whether it is correct or not. You observe here, terminal point of first vector, initial point of second vector, both are same. So AB bar plus BC bar can be written as AC bar. AB bar plus BC bar can be written as AC bar. AC bar minus AC bar. You observe here, AC bar minus AC bar, same vector. AC bar minus AC bar is clearly zero vector. Here also they are saying same thing. So this is true. So now I need to check this. You observe AB bar plus BC bar. AB bar plus BC bar is what? This is AC bar. AC bar minus CA bar. You observe this is AC bar, this is CA bar. Both are different. Here I will simplify this further. AC bar, you observe here, minus CA bar can be written as AC bar. Negative of a vector CA bar is AC bar. We learned this in the definition of negative of a vector. Minus CA bar can be written as plus AC bar. AC bar plus AC bar is what? This is 2AC bar. When I simplify this left hand side part, I am not getting 0 bar. I am getting 2 times of AC bar. So this is not true. This is not true. You observe AB bar. Minus CB bar, negative of a vector CB bar can be written as BC bar. Minus CB bar can be written as plus BC bar. Okay, plus CA bar. Now if I simplify this, you observe BB, AB bar plus BC bar is what? AC bar. AC bar plus CA bar. AC bar plus CA bar. You observe CC is there. AC bar plus CA bar is what? It is AA bar. What is AA bar? AA bar is 0 bar. I got this is also true. What they are asking in the question, which of the following is not true? So third option is not true. I hope you understand this. This is easy only. Now last question of this exercise. You observe this 19th question. A bar, B bar are two collinear vectors. To understand the solution of this question, you must know the definition of collinear vectors. If you know the definition of collinear vectors, you can do this very easily. Okay. Then which of the following are incorrect? You need to identify which of the following is incorrect. Wrong one you need to identify. First option you see, B bar equal to lambda times of A bar. You know that collinear vectors are also known as parallel vectors. How we prove two vectors are collinear? If we express one vector as scalar multiplication of other vector, then we can say that the vectors are collinear vectors. This you learn in the definition of collinear vectors. If one vector is expressed as scalar multiplication of other vector, then we say that those two vectors are collinear. Collinear vectors are also known as parallel vectors. Okay. You observe here, first option, b bar equal to lambda times of a bar for any scalar lambda. That means one vector is expressed as a scalar multiple of another vector. So, if the vectors are collinear vector, this holds good now. One vector can be expressed as scalar multiplication of other vector. This is correct. They are asking which of the following is incorrect. This is correct. Okay. You observe here, a bar equal to plus or minus b bar. Plus or minus b bar means plus or minus 1 into b bar. Here also a bar is plus or minus 1, that is scalar, into b bar. Here also, in this statement also, you can identify that one vector is scalar multiple of other vector. So, as they given the vectors are collinear vectors, this option also holds good. Here also what is there? One vector is scalar multiple of other vector. Now, see this third option. The respective components of a bar comma b bar are not, look here, not proportional they given. Here, collinear vectors are also known as parallel vectors. Collinear vectors are also known as parallel vectors. In parallel vectors, the respective scalar components of given vectors are proportional. Parallel vectors, the respective scalar components of a bar comma b bar are proportional. We know that point from the definition. Here, they are saying that they are not proportional. So, this is incorrect statement. So, I'll see this is incorrect statement. Now, let's see this fourth one also. Both a bar comma b bar have same direction but a different magnitude. They are in the same direction. They are in the same direction means that itself indicates they are parallel. Their magnitude may be different. It's okay. No problem. Here I can say the vectors are parallel vectors. Parallel vectors are also known as collinear vectors. If the vector satisfies this condition, then also we say that a bar comma b bar are collinear. So this is also correct statement. But what they are asking, which of the following is incorrect? See, this third statement is there, na? That is the incorrect statement. I hope you understand this class. With this, all second exercise problems completed. Next topic is about dot product of vectors. If you like this video, please drop a like for this video and share this video with your friends so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye.